Hi, in this video I'm going to do reverse engineering of this side mirror cover. It's a Lexus IS250 from the year 2006. This was sent to me by a viewer from this channel. He wants me to demonstrate how to reverse this part from the 3D scan data. This mirror cover is almost 20 years old. It's possible that if you break it, you're not going to be able to find a replacement part because most of the Japanese car manufacturer they will keep their part stock for 10 years after they stop manufacturing the car. If you want to get the replacement part, you probably need to find it from the junkyard. Okay, the part is made from injection mold ABS plastic. It has a standout edge here that represents the letter L, I think, which is the Lexus logo. Okay, so if you look from the inside, the side mirror contains a lot of mounting holes and clips. I can count 7 fixing points on this. So I will model the clips and the mounting point separately, because if I print it together with the cover, it's going to break easily. Okay, this is the scan data that the viewer sent to me. He scanned the outer shell and the inner shell with the 2 separate scans, and then he merged it together. And the thickness of the wall is somewhere between 2.6 to 3 millimeters in some part. And the scanner that he used is the original Raptor from last year. Now it's cost about $1,000 US. And he used a 7-line blue laser mode to scan this part. Okay, so the detail of the scan is very high. 5.8 million triangle, and this one is 4.5 million triangles. He also made a scan of the fixing points. It's quite important if you want to reverse the thin shell. You need to scan the mounting point, know what kind of space you have, so that you can decide how would you modify the clips. So in some part the scan is not totally captured this part. To reverse this, I'm going to export the model as a point cloud, and I will also export this mounting point as well, and then I will align these 2 point clouds together in the cloud compare. Okay, next I'm going to align the cover to the frame. I need to find some flat point so that I can align it to the XY plane. And I'm going to move this to the origin point, 0, 0. Let me turn on the cover. So I'm going to merge this 2 parts together. Cloud Compare has a merging function. I'm going to click on this function. So it's going to ask you what will be move object and what will be a fixed object. I will choose the cover as the moving object. And next you are going to choose 4 points. So I'm going to click here. This is the first one, A0. The next point, three points. Let's see, align. Okay, now it's aligned. You need only 3 points, not 4. And click on check mark. So when you slice it, you can see the space available for you to modify the clips. And if you want to change the shape, you will know how much space you have left. And if you look at here, this is the rainwater protection system of the mirror cover. So if the rainwater gets in here, they have a special void here for draining the rainwater. The water will be trapped inside here, and it will not overflow to the internal mechanism of the side mirror. And if I keep slicing this channel, it will go down to this mounting. The water that trapped inside the channel will flow into the side door of your car. This is the same for most cars, I think. So this water trap channel here is only on the top side. There is no rainwater protection for the bottom side. Okay, so next I'm going to import into Autodesk Inventor. In the Autodesk Inventor, this is the import point cloud. So I'm going to turn off the mounting. I focus on the cover first, and when I design the clip, I turn on the mounting point clouds so that I can check the available space. One of my videos I have already demonstrated step by step from the point cloud to making a first sketch on the Autodesk Inventor. So in this video, I'm going to go fast. And the function that I use is only two functions, a loft command and extrude command. So this only two functions. I would say you can draw anything. Okay, so we have it, the Lexus side mirror. Okay, let's save this as the step files and send it to the slicer for 3D printing. Okay, here's in the slicer. I like to export the CAD file as the step files because most of the slicer today they can open the step files. The slicer will convert the step files into a mesh. It cannot display the model from the step file. So in fact, the step file that you import will be converted into a mesh. Between the step files and the STL, the step file has a smaller file size. This whole assembly is only 2.5 megabyte. I have a clips included in the assembly. So if I export it as the step files, I can export it in just one time. I can split it into the objects like this. Sometimes I need to repair, import model from the step files, and I'm going to put this end onto the build plate. So I'm going to print in this orientation. Arrange it. I will need to use the L3 support, and I'm not going to use any brim. Okay, let's send it to the printer. I can see that the overhang is too much. I didn't put a support there. You're supposed to put adhesive in before, so this is the first one. Okay, this is the second one. This is the third one. So I use 0.1 millimeter for the clearance of the dovetail, so it's fit quite well without the adhesive. Okay, so I have a very tiny small clips. It's very difficult for me to see this. Okay, let's check the result. I haven't sanded it yet. Just trim with the side clipper. This is one of the defects here, that I didn't put a support. If I put a support here, it's not going to happen. The overhang is too much, and this is what I expect. So this is the part with the support. When you reverse with CAD, you have a full control of the standout edge and curve of the object that you are reversing. So if you do this with the automatic surfacing tools, you are not going to see this. It's going to blend out. This would be a layer height. I can use a filler to fill this. And for the joint, the dovetail joint works quite well for this mounting hole. This one also. This one is a bit too small for a dovetail. I should simply make a wider base and glue it directly to the shell. And these two clips also work quite well. You don't even have to put in the adhesive. Just use 0.1 millimeter clearance and it will press fit very well. So if you break the clips, you just simply remove it without printing the whole new part, which take a long time. This one was 6 hours of the printing time. Okay, so this is how I do it. Reversing the side mirror with just a loft and extrude command. Thank you guys for watching. I'll see you in the next video.